All right, 8.2, removing perfect square factors. I've left everything up here from the last section as far as my list of perfect squares, my perfect cubes. I've still got the radical notation written up here so that we can still see where the index goes, where the radicand is, where the radical is. Hopefully you've started to get that down pretty well by now. But let's move on. We're going to move on to the product rule for radicals. All right, so what does product mean? Product is the answer to a multiplication problem. So the product rule for radicals. The last section we talked about the quotient rule. We determined that if you have a fraction underneath a radical that you can break it apart. Now we're going to deal with the product rule. So if I have the nth root of a times b, right? So all that's saying is I have some root. It could be the square root, the cube root, the fourth root. It doesn't matter what that number is. I have the nth root of something times something else. If I have the nth root of something times something else, I can break those apart just like I could with a fraction. That's going to be the nth root of whatever the first thing is times the nth root of whatever the second factor is. All right, so I take the two factors and I break them apart as separate radicals. All right, where that helps us a lot, because it won't always look as obvious as something times something. If I have something like the square root of 32, when we first look at that, we don't see a product. We don't see factors. This is a product. There's a lot of factors of 32 that would make it a product, but I'm not seeing them. All right, so what I need to do is, and if you're really good at your multiplication tables, particularly if you've got your perfect squares memorized, this list over here, what I'm essentially going to do is to take 32 and I'm going to list all the factors of it. You won't have to do this every single time. You're going to get to where you know which one it is in your head. But the factors of 32, other than the prime factors, I don't care about 1 and 32. I get 2 times 16. I get 3 times 8. I get, what else am I going to get? It's not 3 times 8, it's 4 times 8. 4 times 8. All right. 6 doesn't go into it, 5 is not going to go into it. I feel like I'm missing one. Yeah, it's not. All right, so I got 2 times 16 and 4 times 8. The only factors I care about of these are the ones that show up on this list, and I've got 2 of them. 4 and 16. Both of those are perfect squares, so 4 and 16 are perfect squares, but what I want to do is to break this up into the largest perfect square factor of itself. So I'm going to say that that's the same thing as 16 times 2. And now it looks more like what I have up here. It's something times something, and I can break those apart. That's the same thing as the square root of 16 times the square root of 2. The square root of 16 is just 4. The 2 is still stuck under that radical. It's in radical gel. I can't get it out. So it's going to be the square root of 4 square roots of 2. All right? What we're doing here is essentially the same as whenever we dealt with rational numbers. I can't leave a fraction that looks like this. I have to reduce that. 2/4 is the same thing as 1/2. Just like I can't leave a fraction that's not been reduced, I can't leave a radical that's not been reduced. If you have a radical that you can pull, especially if it's a square root, that you can pull a perfect square out of it, we need to do that so we can pull it out from under the radical. All right, and we'll do some more practice ones, but this is essentially what's happening. Going forward, I may not show as many steps. I'll do them just like I would do them on my paper. All right, so let's look at another one. Let's do 7 square roots of 54. Not worried about the 7 on the outside, nothing I can do with that. I just need to worry about 54. Is there a factor of 54 that is on this list? I know that this is the same thing as 6 times 9. 9 is a perfect square, so that's the same thing as the 7 square roots of when I do this, I always put my perfect square factor. I could do 9 times 6, or because multiplication can go either way, I could do 6 times 9. I always put my perfect square up front. So 9 is the perfect square. I do it like this. The reason being is, at this point, I understand that they break apart, but I'm not going to show that break apart every single time. I'm going to see that this 9 can come out. I'm going to write that it comes out as a 3. All right, so that 9 comes out from under the radical as a 3. And what I have to do with that 3 is multiply it by whatever is already out here. So I've got a 7 out here. 3 times 7 is 21. The 9 is gone, but the 6 is still stuck under that radical. So I now have 21 square roots of 6. All right, so the trick is always, is there a factor of this radicand that is a perfect square? If there is, break it apart, put your perfect square up front. If you want to show it like this, that's perfectly fine. Break it apart like we did on the first one. That would be 7 times the square root of 9 is 3, times the square root of 6. 7 times 3 is 21. Square roots is 6. So we still got the same thing. Either way is fine. This is just the way I prefer and the way that I do it on my paperwork. And if I was to do a test on this chapter, this is exactly how you would see it. I wouldn't skip any of these steps. I would show my step every step of the way. That way, if I make a mistake, I can find it back pretty easily. All right, so let's look at some of the letters in these. Again, most of us hated it when letters came into play, but a lot of times the letters are easier. If I have 12, the square root of 12x squared, I'm going to deal with them. Now I do have an a and a b. I have a 12 and I have an x squared. Just like before, I'm not going to break them apart like this. Again, you're welcome to do that every time, whichever way is better for you. I'm going to look at the 12 first. Is there a factor of 12 that is on the list of perfect squares? Again, I've got the 4. The 4 goes to the 12. So that's the same thing as 4 times 3, and I still have the x squared. The x squared, if I can pull it out, I need to pull it out too. It's a whole lot easier. I don't even have to think about it very much. The index, whatever the index is, if this exponent is divisible by that index, then this is a perfect square and it can come out. All right, so the 4 is going to come out as a 2, and the x squared, that's going to come out as an x squared. 2 divided by 2 is just x to the first, so it comes out as an x. So on the outside, I'm going to have 2x. Square roots of the 3 is still stuck under there. All right, so I do them one at a time. I deal with my number first, and then I deal with whatever my variable is. And there could be a whole list of variables. It could be x squared, y cubed, z to the 4th. And I'd have to deal with each variable separately, but they're just as easy as this one. All right, let's look at one that may be a little bit more complicated at first. Let's say we've got, let's do the square root of 32 x cubed y squared. The factors of 32, we talked about those earlier. We know that it's 4 and 8, 16 and 2. 16 is bigger than, 16 is a perfect square. So I can pull it out. It's going to be 16 times 2. Now my x cubed. My trick here, 3 is not divisible by the index. The index here is a 2, it's understood to be 2. 3 is not divisible by 2, so I need to break x cubed up into 2 parts too. X cubed is the same thing as x squared times x to the first. Anytime that I'm dealing with a letter, all I'm going to do is I want to take this to the biggest number smaller than the exponent that's divisible by the index. So because this is squared, all I need is an even number. 2 is the next biggest number under 3. So I'm going to break it up into x squared times x to the first. Y squared is already even, so that one's fine. Now I need to start bringing everything out that I can. 16 is going to come out as a 4. The 2 is going to be stuck under there. X squared is gonna come out as an X because 2 divided by 2 is X to the first. That one's done. Y squared is gonna come out as a Y because squared 2 divided by the unrestricted 2 is 1. That one's done. So when I get on the outside, 4xy, these three that came out, times the square root of everything that's still stuck under there, 2x to the first. All right. So on letters, let's look at another one. Let's do a cube root. Let's do like the cube root of y to the 10th. All right, I'm looking at the exponent. What's the biggest number? If 3 will go into 10, I just pull it out and divide the 10 by 3, but 10 doesn't divide by 3. What's the biggest number smaller than 10 that is divisible by 3? Well, that would be 9. So that's the same thing as the cube root of y to the 9th times y to the first. Y to the 9th is going to come out as y to the 9 divided by 3 is y to the third. So I'm left with y cubed square root of the y still stuck under there. That's as far as I can go. All right. Takes a little bit of practice. Once you've done a few of them, this part is pretty simple, but again, you really need to be good at your perfect squares, have those memorized, and be good at your multiplication tables. So maybe not just have flashcards for your perfect squares. I would probably freshen up on my multiplication flashcards too. You get good at that, factoring, reducing radicals, all these things get a whole lot easier. All right, that should be it for 8.2. We'll come back to 8.3.